Hello everyone. In this video we're going to be solving a functional equation. This is a problem that I came up with, but again these problems are not really hard to come up with. So we have f of x plus 1 over x equals x minus 1 over x, and x is supposed to be greater than 1. So we're kind of restricting the domain here so that our function has a valid inverse. Okay, so let's go ahead and use substitution here to find f. So I'm going to call this stuff inside the parentheses. A lot of times if you're trying to find f of x from f of something else, it would definitely make sense to call that gigantic thing inside the parentheses, like set it equal to something, another variable obviously. You don't want to set it equal to x because that would involve solving some equations, which is something you don't want to do. Anyways, so I'm going to call this whole thing y, and you know why, hopefully. So it means that x plus 1 over x is equal to y. Great. And the question here is basically, if x plus 1 over x is equal to y, if I can express that in terms of y, how can I express x minus 1 over x in terms of y though? So that's going to be our question, right? Interesting. Okay. So let's go ahead and establish a relationship between these two quantities. So let's go ahead and square the first one. So if you go ahead and take this expression right here and square both sides, we're going to be getting x squared plus 1 over x squared plus 2ab, but x and 1 over x is going to cancel out, and that's going to leave us with a 2. By the way, this identity is commonly used, so get used to it if you're dealing with algebra. If you're doing factoring, definitely this is something that comes up very often. And we want to do the same thing for x minus 1 over x, so let's go ahead and square x minus 1 over x. And we get something very similar, and that's going to be x squared plus 1 over x squared minus 2ab. Again, it's 2 times x times 1 over x, but it's just going to turn into a 2 there. So we're going to get something like this. So we have two equations, basically. We know that this is equal to y squared, and we also know that x minus 1 over x squared is equal to that. So we're going to put these two together. In order to be able to do that, let's go ahead and substitute this into our first equation. But in order to substitute, I don't have x minus 1 over x in the first equation. So let's go ahead and isolate x squared plus 1 over x squared from here. So this is what I would like to isolate from the second equation. So let's solve for that. Add 2 to both sides. And you're going to get the following. Great. Now, this is something that I want to substitute here in my first equation. And if I do that, I'll be able to associate x plus 1 over x and x minus 1 over x. So x squared plus 1 over x squared can be written as x minus 1 over x quantity squared plus 2, right? So that basically replaces the 2 in the first one. And then I have to add another 2 to it, right? And that is going to become y squared. Awesome. Now, remember, I was trying to get y squared. Actually, this is not what I want, but I'll get to it anyways. Okay, yeah, I was trying to get the x minus 1 over x. So here's what I would like to do. This is 4, so let's go ahead and subtract 4 from both sides. And we get y squared minus 4. Now, you could arrive at this result a little faster if you already knew the identity. Let me tell you what it is. So we have this really useful identity in algebra that it's very helpful, especially in factoring and for solving some equations. If you subtract these two quantities, we have 2ab and then negative 2ab, but they're being subtracted. We always get 4ab. So if you apply that to our situation, you're going to get the following. X plus 1 over x squared minus x minus 1 over x squared is going to give us 4 times x times 1 over x, but it's just 4. See? You could definitely arrive, and this is definitely y, so y squared minus that equals 4, which is the same thing that we got. Okay, great. So our goal was to get x minus 1 over x squared, not squared, but x minus 1 over x, but we can easily square root that. But at this point, we have to be careful because there are two numbers basically whose square equals y squared minus 4. So we have to use the absolute value here. Let's go ahead and use absolute value while square rooting this left-hand side. So I'm going to write absolute value of x minus 1 over x is equal to square root of y squared minus 4. It's equivalent to writing the plus minus, but this is more meaningful because now we know when it's a positive and we know when it's a negative. Remember, we were given an additional condition that x must be greater than 1. So since x is greater than 1, let's see what that means in our context. X minus 1 over x. So if x is greater than 1, let's think about it. For example, if x is equal to 2, 2 minus 1/2 is a positive quantity. Great. How about 1.1? Well, 1 over 1.1 obviously is going to be 0.89 something. So it's going to be less than 1. And when you subtract, you're going to get a positive answer again. So in other words, if x is greater than 1, then x minus 1 over x, oops, I'm kind of ahead of myself here. If x is greater than 1, then x minus 1 over x is always going to be positive. And you can easily check that if you solve this as an inequality, you're going to notice that x is greater than 1 is one of the intervals for which this is true. Anyways, now since we know that x minus 1 over x is going to be positive on that interval, this absolute value can be dropped, and we can write it as x minus 1 over x equals the square root of y squared minus 4. And now remember, our equation, the original problem was given as f of x plus 1 over x is equal to x minus 1 over x. Again, with the condition x is greater than 1, well, we already used that. And we started off by setting, remember, this equal to y. And now we realize that x minus 1 over x can be written in terms of y as well. From here, we get the following. F of y equals square root of y squared minus 4. And if you just replace y with x here, you're going to get f of x equals square root of x squared minus 4. So they kind of gave us the value of f in terms of x because we were looking for f of x. Sometimes in problems, I don't state what the question is, but hopefully it is understandable. Like if I gave you something like this, what do you think I should be asking for, right? Or what could I be asking for? Obviously for f of x, right? What else could it be? If I was asking for f of 5, then I would definitely specify it because it's a numerical value. But otherwise, if I don't state anything, you should know that it's the obvious question, like it's f of x. Obviously, if I'm asking for f of 2x, you can find it too, but f of x would be more important here. Anyways, hopefully that made sense. So we got f of x from here, but let's explore this a little bit further, just like real quick. For example, if I replace x with 1, this is going to be undefined. So x is not in the domain of f. It was previously, defined that way, but in this case, we are running into some trouble. But if x is equal to 2, for example, then we'll be fine, right? F of 2 is going to be 0. And in the original problem, if you go back to the original problem, if they asked us for example, I hope I'm not talking too fast. Sometimes I do. Anyways, so if they asked for f of 2 and gave us this equation, I don't have to find f of x, right? Because what I have to do is just set this equal to 2 and then find the x value from here. And interestingly, you're only going to get a single x value for which this is true. So if I set it equal to 2 from here, I get x equals 1. And if I plug in x equals 1 on the right hand side, I get 0 as before. And this brings us to the end of this video. Thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you tomorrow with another video. Until then, be safe, take care, and bye-bye.